Cool. I think we're actually live, which is awesome. So let me just reset my little counter over there, and we should probably get started. So before we get started with my talk, a big thanks for the DDD community. Kind of without these events, usually I do these in person, these events, which are kind of a bit more, you get to speak to a lot more people than kind of just presenting online, sat in my own room. But these are great events to kind of share knowledge and kind of mingle with people in the developer community. They have a code of conduct, which I've been told to present. So the few points on here is be aware of others, be welcoming and respectful, be understanding of differences, be friendly and patient, be open to all questions and viewpoints, and be kind and considerate to others. So generally just be a nice person, and that's about it. But if you have any problems, there's a bit of link over here, which you kind of might want to use if you have any problems. Also, they usually have sponsorship. I think they've still got some sponsors as well, but they're kind of trying to, kind of people kind of help out, fundraise support for the National Museum of Computing. I've never been to the National Museum of Computing. I feel I should probably go. There seems to be quite a lot of interesting things. I've been to their website, and yeah, it's probably quite a good day out, to be fair, once kind of if we get over the COVID situation. So here's a few of the sponsors. So big thanks to these guys. We won't be able to kind of put these kind of events on without sponsors, obviously. So big thank you. And also there's some social feeds as well. So we have the hashtag DD 2020, the @developer days, and just enjoy yourself. So we'll get on with my talk. This is not my talk. If you kind of signed up for everything you want to know about Kevin Smith, I'm not going to be talking about myself. That would be a pretty dull talk. A bit of CSS failure there on that part. So what we're going to talk about is .NET configuration. But before I start, a bit about me. So I'm just a normal C# developer. I do a bit of JavaScript as well. I run two .NET groups, .NET York and .NET Chef. So that's in the York and Sheffield. I kind of play around with quite a few open source software as well. And if anybody have got any kind of questions afterwards or kind of want to poke around on my GitHub, just at kev_byte to kind of contact me. So today we'll be covering some bits and bobs about the .NET configuration. So this will be the basics, so kind of how to get started with it, kind of what the kind of main kind of bits and bobs are. And we'll go about the providers, and these are the things what kind of provide the data for the configuration. There's also some defaults in ASP.NET Core, which we'll kind of go into. And then we'll go into the kind of how we bind that into kind of some kind of models and how iOptions is used. We'll touch a bit into dependency injection and also how we can validate as well. So let's kick on with the basics. So a few things what we're not going to be talking about to start off with is the system configuration. So this is the old kind of namespace inside of .NET Framework. And this includes, we're not going to talk about the system.configuration manager as well. And this is actually a NuGet package. So you can actually run the old kind of configuration manager on .NET Core and .NET 5 if you really want to. I'd kind of totally avoid trying to do that if you kind of, because it's not a great idea. But if you're kind of trying to migrate an older legacy application to .NET 5, that might be a kind of a way to make it a bit easier for you. So this includes the the configuration manager, which is the .NET 2 Plus and .NET Standard version, and there's also configuration settings, and this is the really, really old school .NET Framework configuration settings. That means we're not going to look at any of this horrible XML file either. So this is the web config or the application config. So we can just totally forget about that. But what we are going to talk about is this abstraction layer called Microsoft Extensions.configuration.abstractions. And these are a bunch of abstractions what Microsoft are now providing for us to kind of build our application. And these also, this is like a bunch of kind of abstractions, and there's also ones which are for login, caching, dependency injection, and localization. So they're kind of building up a list of kind of different abstractions. So these are like interfaces which people can implement. And one of them implementations is the Microsoft version of it. So Microsoft have created their own implementation of these abstractions, which you can use. But that doesn't mean you can't create your own. So if you've got your own company X, they can create their own abstractions and implementation, and I can create my own as well. And that's totally valid. So it's kind of can be used anywhere. It's all built on top of the .NET standard, even though they bumped the version up with the .NET framework. So now we're at version 5, I think it is, to kind of join up the kind of 2 version numbers, .NET 5 as well, when that was released. It can be actually run anywhere, so on .NET framework, .NET, .NET Core, etc., which is great. So as I went over, this is implementation of the abstractions of the configuration stuff. We can install it from NuGet directly. It has a concept of configuration providers, so these are kind of where it gets its data from. By default, it includes an in-memory provider, which we'll play around to start off with. And it also has a kind of way to kind of have a callback for when changes happen within inside the configuration, and I'll show that later down the line. So at its kind of heart, it is literally just a key value pair of data. So we have a bunch of keys. So you have key 1, key 2, key 3, and these relate back to these values. And that's pretty much all it does. So when I say I want key 1, it gives the value for key 1, it gives me value 1. We can also kind of represent hierarchical data structures as well. So we might have most applications, you might have a bunch of services where kind of things depend on different parts of configuration, and we can make a hierarchical structure of that. So for this example, we have Twilio. And then within Twilio, we might have a base URI and an API key. And we kind of denote a hierarchical structure like this with a colon. So we just put the 2 keys next to each other with a colon between it. So we have Twilio, colon, base URI, Twilio, a colon, API key, and we can put 2 values like that for that. We can also have just a root one like this environment one here. We can just not put a colon and just have it like a normal one with the value set. And then we can also have maybe one which is features. We have a menu and a splash, which we can set to true and false. So all the keys are strings, all the values, are strings, and all the keys are strings. And the keys are actually case insensitive as well. So for these examples, example is the same as saying example. So uppercase example is the same as lowercase example. And having a key which is kind of multi-case can just match straight to like an uppercase one as well. And that's completely valid. And makes it a bit easier to kind of fetch your keys out. So I'm just going to show a bit of code off to show the kind of basics of kind of how we normally set this up as like a raw example. So to start off with, we create this configuration builder, and part of that configuration builder has a build method which gives us the root configuration for it. And with the configuration builder, we kind of have lots of kind of different methods on here, and also extension methods, which we can pass in different values for different providers. And this one's just going to be using the in-memory collection, and the in-memory collection just passes a bunch of values, and this values is just a dictionary. And this dictionary is string. So like we showed in the other slides, we have a key and a value. We can have a hierarchical key and a value as well. But to get our kind of data out, once we've built our configuration, we get our configuration object, and we can just call the indexer and pass in the keys what we want. So you can say we want key 1, or we want key 1 colon parent 1 colon key 1, and that'll get us a value. And these will be the string values of what our key represents. So we can also kind of get sections, so that if you look at our kind of hierarchical tree, so where we had Twilio and our URI, we can get a section out. So you just pass in the actual top level of the key. So we've got parent 1, and then we can drill down into that section and say I want key 1 and key 2. So we can keep drilling down into them sections and getting more sections as well. Sorry, my vote's getting a bit like dry already. So we can also subscribe to reload notifications as well. So a provider might kind of, if it's a file on disk, it might change, and we might want to kind of reload that configuration at kind of runtime. And the application might want to respond to that based on it might change and have a pop-up saying like the configuration has changed. or we might want it to like push the user back to like a main screen or something else like that. And we can do this with the reload tokens. So part of the configuration, we can go ask it for a reload token. And once we got that reload token, we can register a callback. So here we're registering a callback, which is just going to write a line to the console which says configuration changed. We can pass some state in it as well. So this is some state, and that state here gets passed across here, but I'm just discarding it here. And once the configuration, you can force the configuration to be reloaded by just calling reload, and this will output configuration changed. And we can also reload it again, but the second time it won't do anything because the first time it's reloaded, you have to re-register the callback. So every time the configuration state is changed, we have to re-register a callback for a kind of change event. So this second one won't actually do anything until we kind of re-register it. So I'm just going to show a bit of a demo on that. So I've just got Rider open here, and these are the kind of examples what I kind of showed in the slides. So we've got a bunch of values, which is our dictionary. We're plumbing that into a configuration builder using the add in memory collection, and then we're just going to get all these values and print them onto the screen. We also can get our section, which is the parent one, which comes up from here, which has two keys on it, it's key 1 and key 2. And we're just going to write them out onto the screen as well. So if I just run that, oh, that's the wrong one. Let's not run that one. Go away. Let's go back to here. I think it's, where's the one? What's this? Is that one? Yeah, so now this is running. We can see our values, which got our tar in memory store. So we have value 1, value 2, and value 3. And then also from the section, we can load the two values at the section as well. The last example is the registering the callback. So we've got this reload token. We register that reload a callback on that reload token and write to the console. We reload it once, reload it twice, and we've just got a sleeper then to make it so it doesn't kind of exit straight away. And that output has obviously just printed one line, and that's it, saying the configuration changed, and the second one didn't actually do anything. So that's just a quick overview of kind of what the kind of main configuration stuff it's got under the hood. So go back to my slides. We can get there. There we go. So I'm just going to cover the configuration providers now. So these are the ways for the kind of configuration kind of manager to get like different sources of data and plumb that into the configuration. So there's many of these providers. The first one we've already touched on, which is kind of already built in, is the in-memory one. There's also a file configuration provider, and this can accept 3 types of bits of data. So this is kind of JSON, XML, and INI files. There's an environment variables configuration, which gets the stuff from environment variables and user secrets. So these are the 4 what I'm going to actually touch on in a bit more depth. There's also a command line configuration provider. So for command line arguments, which you pass in on kind of the command line, there's an Azure configuration provider and a Azure Key Vault configuration provider in case you're kind of storing kind of secrets within kind of Azure and you want your application to fetch them at runtime. But there's lots of community provided ones, so there's some AWS ones, and you can also kind of build your own as well. So if you've got kind of a need to kind of build your own provider to fetch it from your own data store, say you're kind of using MongoDB to kind of store all your kind of configuration, you can write your own for that. So we've already gone through the in-memory one, but this is kind of just another example. We just call this add in-memory collection, and that kind of sorts out for us based on this data what we've passed in as a dictionary. So I want to show that one just because it kind of relays into the rest of them. So the file provider kind of is broken up into kind of 3 providers. We've got the INI one, the JSON one, the XML one, and this is like every single other provider. They're all in separate NuGet packages. So you only need to take a dependency on whatever you need to take a dependency on. So if you're not just pulling in all the file providers, you can just pull in the JSON one if you need the JSON one, or pull in the XML one if you need the XML one. So it makes it a bit more kind of lean. So the file providers are kind of set up in a similar way. We've got some extension methods on this configuration builder. We pass in the first parameter. What we pass in is the file what we want to kind of load from disk. We also have another parameter called optional. So if this is set to true, if the file's not there, it'll just ignore it and continue on that normal. If it is not optional, the actual configuration builder will blow up at runtime as soon as possible when you call build, saying the file doesn't exist. So this is really useful if you kind of got some required settings in a certain file and you kind of don't want the application to just kind of ignore them and just continue running. You can blow up as soon as possible and fail fast. We also have this reload on change as well. So this goes back into the kind of the callbacks what I showed earlier. If this is set to true, it kind of monitors the file on disk. And if the file does change, it gets a notification to the configuration and then tells it to reload that from that provider, and then everything will update. You can also set this false, and it'll just kind of ignore any changes from then on. So at the ini provider kind of maps like this. So we have keys, and we also have sections with keys inside them, and they kind of just get flattened down into, for example, this one says ini file and then the value, and then the one with the section gets flattened down into the section name, and then also the key and its value. So the JSON one, very similar, but in the JSON structure. So it just flattens the whole JSON structure down into all the keys separated by this colon in the same way, just as we kind of registered the kind of in-memory one, really. And the XML one, totally the same as well, except for an XML. So we have some lovely XML, which is a lot nicer than the last configuration .NET built, and it just gets flattened down. So the next one up is the environment variables. So these are a bit different because not all platforms support a colon with inside the environment variables. So we can either replace, if your platform doesn't support a colon, we can replace it with a double underscore. So if these are things like in Linux or Bash where we can't use colons. We can also, because the kind of configuration is all in case sensitive, that means we can use any kind of environment variable kind of conventions what we have already. So for example, in Bash, we kind of create uppercase environment variables. We can still keep them and plumb them straight into our application. It does mean we do actually kind of have another separate NuGet package for the kind of environment variables as well. So if you want to pull that in separately, you can do that. And this is kind of how you set up. So there's actually no arguments for just the default configuration, which loads all environment variables in. But we can also kind of just load like a subset of environment variables with like a prefix. So you might have your product name, product A, which is a prefix, an environment variable. So then it doesn't load like everything out of the environment variables, which can be useful if you're running many applications on one machine. So here's a few examples. So this is like in Bash, if we export this environment variable out, we've got the double underscore here, and this will map into this colon. We can also do the same in PowerShell, so we can use double underscore, and that'll map into the colon, or we can just use a colon in PowerShell, and PowerShell will just be like, okay, that's fine. So that'll map into exactly the same key. So all these three examples will generate the same key for the same value. So the next one is the user secrets. So these are a way to store sensitive data for development only. So it's not actually really used for production. Well, you shouldn't be using it for production at all, really. And you kind of have a secret ID, which is embedded inside your assembly, which is kind of done at build time, and it's put into the CS proj. So you'll end up with a kind of XML tag, which says user secret with the GUID in it. And this relays back to a JSON file provider, actually, which is trying to load a JSON file off your file system. So on Windows, this is stored in your app data, and on Linux and Mac, it's actually just stored in this root directory. And the user secret ID is replaced with what is in the CS proj. And it is literally just a JSON file. So the JSON file is not encrypted. So don't store kind of production kind of keys in here, in case it could just get compromised. and that is also just a separate NuGet package as well. So this is kind of how you plumb this in. It's very similar to the file provider one, except for now we kind of pass in an assembly, and this is the assembly for where it finds the actual the ID for the user secrets. So we either can pass an assembly itself, or we can just use a generic method, pass in a type, and wherever that type lives in that assembly, you'll go load it from that assembly. So we can access these using the CLI as well, which is quite useful. So during development, you probably in your project directory, you can call .NET user secrets init, and that will set up generate you a unique GUID and plumb it into your CS proj. And then from that, you can set keys on that, which will get stored in your secret file. So you can just call set with the key and the value. And so you can do that many times with different keys. We can also list all the secrets by calling list, and this will just print all the keys and all the values for it. We can remove individual keys as well out of the secrets, and we can also just clear it. So these are kind of some useful commands that you can use. And one of the other interesting kind of providers you can use, which is kind of already built into the base NuGet package, is being able to build configuration from configuration. So this is a bit of a link using the aggregate like kind of extension. So we're taking in a bunch of configurations. So these are the things what we're building originally. So we can build these from any of the builders, and we can build another configuration from the configuration. So it's actually used at the startup of the ASP.NET Core apps. So the internals actually creates its own configuration, and then it actually builds another configuration on top of that. Ordering does matter when you're kind of building up those different kind of providers. So for this example, we've got 3 in-memory collection providers. And in these in-memory collection providers, we've got the same key for every single one of them, but they all have different values. And how this works is the last one wins. So because this is the last one that can provide this key for item, this actual console.write line will actually just output 3. Because that was the last one in the list what can provide this value. So this is a really good way to kind of override values. So if you might have a settings file with loads of different variables, and then you might have a bunch of environment variables for a given machine or many machines, to just tweak these kind of variables to kind of override the actual base variables. And from that, it kind of might get a bit confusing where all these kind of all this data is coming from. So there's actually a useful extension method on top of the configuration, and this is called get debug view. And I don't think many people know about this, because there's kind of a lot of questions out on the internet about kind of how do I find out where my configuration comes from. And because we've got all these different providers and we have like a kind of the ordering kind of makes a difference, it's kind of really hard to kind of debug. So if you call this get debug view, we get this file, this output here, and this gives us all the keys what we've got within our providers, and then also tells us the values, the actual values what it'll get when you actually go fetch that, and then it also tells us what provider it comes from. So this event DDD came from the in-memory configuration provider, but this ini file loaded from ini file actually came from this ini file configuration provider, which came from this file, and it also tells you if the file was optional as well, which is interesting. So it does it for every single variable which is actually loaded, which is really useful. So I've just got a bit of a demo kind of them ones. So if you flip back to Rider, so providers. So here's a kind of exactly the same kind of setup I showed on the screen. We have in-memory one, what's been set up. We've got the same code down here to set them up. So I'll just pull that into separate methods. You've already seen that code. You've got the environment variable ones, and then we've got the all configuration one as well. And then we're just kind of printing the debug view here, and we're also printing one of the single items out here to show that. So if we kind of just run that, you can see a little example of this. So this is kind of an example what I kind of showed in the screen. So this is loading from the ini file, and the JSON file and the XML file. We've got one loading from the environment variable, and then we've got the debug view as well. And then we've got the example of the kind of last one wins example here as well. So that's a very short example. So let's step back to the slides. So the web host for ASP.NET Core web apps actually has some defaults. So if you've ever created like a ASP.NET Core app, it just magically kind of just loads some configuration, which might be a bit surprising. I think the earlier versions of .NET Core 1.1, I think it was, and maybe 2.1, I can't remember. Actually, it specified these in the actual program CS, so it's actually quite understandable where they came from, but they're kind of hidden away now. So this is kind of what our program CS normally looks like for a default web app, and we have this thing here, which is the create default builder, and it passes in some args, and this is where all the magic kind of happens. So within here we have a configuration, which actually a previous one we built for itself, which is the first one it actually uses. And then it uses the app settings.json, so it uses the file provider one. And then it uses another set of app settings with an environment variable passed into it and JSON file. So this variable comes from the ASP.NET Core environment. And if that doesn't exist, it actually just uses the .NET environment as well. So this is a really good way to kind of store some general app settings for your product. And then if you need to override anything for like production or UAT or QA, you can do this in the app settings.qa.json, as long as you set these environment variables to say QA or UAT, for example. By default, if the environment variable is not set, it'll just be production, and that's how it works. The next one is plumb in the app secrets. So this is the user secrets, which we showed before. And this only plumbs them in for development environments. So it's for you to kind of store your own data and kind of run it inside your web app. And then last of all, there's environment variables. So these take the most priority. So if you got anything in your environment variables, they'll come last. So the next bit I'm going to talk about is the options and bindings. So to start off with, a binding takes some configuration data. So these are our kind of hierarchical keys. And then just plumbs it into a type-safe object for us. So this can support things like strings, ints, longs, GUIDs, date times, time spans, and it can also create complex types as well. So if this was a kind of example of an example, that would also be supported. So the bindings are actually built on top of the Microsoft extensions.configuration.abstractions. So this is the one what I said Microsoft implement themselves, but you can also implement them yourself as well. So this means if you use the binder, the binders will actually work for your own implementation as well, which is quite interesting. So if I created my own configuration manager, this will also work for them. So the option pattern also is the kind of recommended way for accessing your configuration. It's to kind of use strongly typed classes, and we can also use records now. And it kind of allows you to adhere to some good software engineering principles, such as interface segregation and separation concerns. So maybe you have, instead of just injecting all your configuration into every single class you kind of have, you can slice them up into like maybe your Twilio kind of options and your features options and things like that. So this is kind of how it kind of works. So all these examples are going to be used in the memory one because they're kind of easier to set up. So we can call an extension method now, once we've installed the NuGet package for the bindings, to say get value, and you can pass in the type what we want to get and the key. And this will then just give us back an actual type, a GUID type. We can do exactly the same thing with a class as well, but this time we can actually use a bind method. So this will go, we can create an object ourselves, and then we can just say go bind all the configuration we can find into these options. We can also pass in a section as well, so it's got a second parameter. So these are got a hierarchical key of example and int. and our options only have the int and GUID on it. So what we can do is pass in the kind of parent key of that of example, and then pass in the options. It'll bind the int and the GUID to this object. And the last of all one is just using the get. So this will go create as this type for us using this generic method and go create these options for us. And we can also do that on a section as well. So if we go fetch a section from our configuration, so this is using the hierarchical key, it'll then kind of just bind to that section individually. So that kind of builds onto kind of the DI kind of setup as well. So when we kind of, in like a normal ASP.NET Core application, you probably kind of register your options with this configure method. And with this configure method, you pass in the configuration where you want to configure these options against, which creates all the binding and everything else under the hood. We can also do a section as well. So you can call the get section and pass that in as well. And that'll work exactly the same to kind of do the binding. But if you want to handcraft this as well, so you've got a console app, you can pretty much just create a service collection. So this is the DI container built into .NET, and you can create a builder, and that's called build, and then you have exactly the same methods on the kind of container to configure them. But this does require you to also install this Microsoft Extensions options configuration extensions NuGet package as well. So you need to install this before you get this extension method on the service collection. So under the hood, it registers like loads of different things for us. Like most things, the things are hidden away, so you don't need to care about the detail. But it's always nice to kind of see what's going off and gives a bit of a better understanding of kind of what's going off as well. So we get this thing called an iOption factory, which kind of is responsible for creating and kind of configuring our options. So we have two kind of methods, which are two interfaces where you kind of register underneath as well with implementations or default implementations for options, which is configure options and configure named options. And this creates the options for us. There's also a one called post configuration, which is really useful for if you want to kind of modify somebody else's options. So say you've got like a framework and they use the kind of options pattern with a bunch of their own kind of configuration values for setting up their framework. You can use this to kind of modify it after it's been built and injected and bind, which we've actually used for kind of a thing called product called Ocelot at our work, which is quite interesting. But the kind of default ones what you probably normally use on a day-to-day kind of basis is an iOptions of T, iOptions snapshot, and iOptions monitor. There's also this thing called an iOption monitor cache as well, where you can say where it gets caches kind of the options, so it doesn't need to keep reloading them every single time. And we'll go into these kind of options in a second a bit more. So the iOptions of T is registered as singleton. It's actually read the configuration at app start, and that's the same configuration it'll support all the way through it. As I said, all these are kind of supports named options as well. So if you have two of these options for two different parts of the system, you can name them so they get kind of injected correctly. The iOptions snapshot is a bit different. So this is actually has a scoped lifetime. So this is for every new scope where you create on the container, you'll get a new iOptions snapshot, and that's when the actual configuration will be loaded. So for example, within an ASP.NET Core app, on a single request, if you use iOptions snapshot of your certain options in two different classes, you'll get the same snapshot of them options. But on the next request, you might get a different set of configurations because the configuration providers provide a different set of configurations for you. So say somebody's changed their file on disk, or they've changed kind of some app settings within inside of Azure, for example. So these kind of interfaces look very similar. This iOptions is like the kind of base interface of it. And then you have the iOptions snapshot, which actually has one extra method on it. And you kind of use it like this. So you kind of, like anything dependency injection related, you plumb it into your constructor. So we've got an iOptions snapshot of T passed in here, and then we can just set this into our class. And when we want to read these values, we can just call this value method here, and then we can then just get our options. So this app options here actually has a property on it called event name, we can get that. The iOption monitor is a bit different. So we can actually get the values from here, the current values of what the provider is actually giving us. And we can also listen to change notifications on the actual these options as well. So this is actually registered as a singleton because we have a handle inside of it to actually listen to changes. So this is a bit of a code example. So we can call on the options, options of monitor, we can call that onChange method, and we can pass in a delegate here. And this gives us, this is supposed to have be a delegate. So we can, it passes as our options which have just changed, and then we can write them out to the console or do whatever else we like. Maybe we kind of want to refresh our application or kind of update some values in it once it's changed. So we can get instant notifications of when options are actually changing and respond to them. It also passes back as a handle as well. So this is an iDisposable, so we're expected to dispose of this once we've used it. So maybe we only kind of register options changing on certain pages, maybe with inside maybe a wound forms application, for example. And we can do that. And once a page has disappeared, we want to kind of clean up after ourselves, and we call dispose. So we can actually just use the using keyword in this example. But if it's a bit more complicated, you might have to call dispose yourself. We can also get the current value by just doing the current value method on it, which will get us the current value out of the kind of options. So I've also got a small little demo of this as well. So if we go over here, so this sets up just a normal standard service collection. We had app settings here, and then we just configure a few bits and bobs. So we configure the app set options here with our configuration, what we just built. We've got two apps. We've got an app monitor and an app and an app monitor. Sorry. We create a service provider here, and then we just run one of our apps. So we run the app one to start off with. So this is literally a forever loop. I like to do my wild truths like this, where you just do for. And then I create an inner scope from the provider, and then we go get a wrap from the actual service provider as well to build it, and then we just call execute, and we just delay for a bit and then execute again, and just keep going round in circles. And then all this kind of app does is taking our options, and we're taking an iOption snapshot at the moment. This means that every time this is built, we'll get a new set of options, and then we can write that event name out to the console. So if I just run that, I'm going to run it over in here instead, actually, so it's a bit more visible. So if we go run that, so this is just looping around indefinitely to just say event name developer. Because it's an iOption snapshot, we can actually go into this config file here, and then we can just put developer. And if you flip back to our console app, you'll see that the configuration has changed straight away, and it's actually kind of reloaded that and it's got that back in, and we can just change that, flip back, and it'll change straight away. So if we just stop that and go back into our code, if we just change this round to be where are we gone? Just an iOptions what injected in, you'll see the difference. So we're now just injecting the iOptions into this app. We'll go back to here and just run it like we did before. And this will just root around indefinitely saying hello. But if we go back into our app sentence here and save that, it'll always be hello, because it's the first, it's actually the first thing what it did when it loaded was actually load the configuration, and then this is going to be hello for the lifetime of the application, or until we create another DI container. So if we close that and run it again, we'll actually get developer printed out. So the last example on here is the monitor one. So if we go with that, So this one is injects an iMonitor options monitor of your type, and what we do is kind of create an onChange event. We write out the event name, and we also write out the current value, and then we just delay for a minute. So I write out the current value to start off with. We've registered a handler, and when we change the configuration, it should tell us about it. So if you go and run that now, we'll get the current value, which should be developer. Oh, actually, that's the wrong name. I think that's supposed to say event name. Let's just stop and change that. Save that. Back. So that should just output developer because that's the value of it. But if we go back into this configuration and then save that, we'll actually get a notification to say it's changed. So this is every single time we change this value now, it'll automatically tell us that the value is actually changed, so we can hook onto that and get change notifications from it. So the last section I want to go over, I think we have like 5 minutes left in the session, is actually validation. So the validation side of options is quite interesting. So it allows us to kind of set up a bunch of validation rules of how we want our configuration to kind of look like when our application starts. And if it doesn't like that, we want to kind of like fail fast. So we just blow up and kind of say the state of this configuration is not valid. And it kind of throws an option validation exception, and that's kind of managed by itself. But we can actually validate by different means. So we can validate by data annotations. So if you've used EF, for example, so Entity Framework uses data annotations to kind of add in kind of validation as well. You can also use data annotations for ASP.NET Core as well for incoming requests and models. We can also use inline validation callbacks for kind of checking what state things are in, and then throwing, returning a Boolean flag if it's valid or not. And if we've got some kind of complex validation, we can also use an validate options class as well. So if you implement this interface, we can write some more complex validation on top of it. So this is kind of what the data annotations look like. So this one's using a regex expression. So we're expecting the name to have an uppercase character for the first letter of A to Z, and then many A to Z letters after that. And then this one's expecting a range on age of 18 to 100. And to make that valid, we can just call this validate data annotations, and that will just throw an exception when we try to access the options. We can do inline validation, like I said. So this is just another method called validate, and it passes the options here, which is O. We can just give it back a Boolean. It's based on like an expression what we evaluate. The other more complex option is we register a singleton. So we've got our I options validate, which is this class here, and that implements this interface of I validate options. And then we get a method which is called validate, and we can just do our kind of logic in here. So this is just checking that age is greater than 18. If it is, we've got success, and if not, we give it back a failure message. And to kind of use that, we kind of have this execute method in our app, and we can get the values from the options here like normal. And once we call this value, it'll actually throw an options validation exception here, and we can print out kind of all the reasons why it failed. If it succeeds, then we just do the console write line like normal. So I kind of sped up a bit towards the end because I've got a few minutes left, but we should be able to kind of fit in this little demo. So we've got an in-memory collection here of values. We also kind of have the service container like we did before, and this one's calling the validate data annotations. We're registering, we don't need to register that one yet. We're registering the app, and then we're just calling the app like we did before and calling the execute method on it. And the execute method is exactly the same as what we showed in the slides. It has a try catch around getting the options, and then if it throws an exception, we kind of bail out. So for this example, we're using the data annotations on this class here. So we expect a name of A to Z, and we also expect an age. So if we kind of change my name to be just Kevin lowercase and age 20, that should be invalid because the name. And if we kind of I'm just going to open it in here instead, actually. So when we run that, we get that exception thrown, and it gives us like a really good explanation why it failed. So we say the name failed for the members with the name with the error of the field must be matched the regular expression, and gives the regular expression which we provided. So that's the kind of way we can do it with data annotations. We can also give it like a callback for validate. So this will be always invalid. So if we run this one, this will just say it was invalid. And then we can just get rid of both of these, and then we can add in this class what we talked about before, which is like a bit more complex validation, but in our case it's just checking the age. So here, if we run this, it'll run perfectly fine to start off with and print out the thing what we expect. But if I change our age to be 10, for example, we can run that, and then we get a validation error message here as well, saying that age must be greater than 18, which comes from our class down here. So I think literally just 45 minutes, which is great. So a bit of a summary of what we've been over. We went through the basics of the configuration, how providers provide the kind of data for the configuration, the defaults for ASP.NET Core, how all the bindings kind of plums together, and how it plumbs into dependency injection, and how we can use validation to kind of fail fast when our app starts up. So there's also lots of links out there on the Microsoft website if you want to read more about this kind of things. So there's stuff about the .NET configuration, and there's also stuff about the options pattern. And option pattern doesn't have to be used with the .NET configuration well. You can actually inline it with inside your code as well if you want to do that. But thanks for listening. I might run over by 45 seconds according to my clock. But if anybody has any questions, I'll happily answer them, and I'll try to get Teams up and have a look, see if we have any questions. Where's the button? Do we have questions? We don't have any questions. Well, thank you for kind of listening, and enjoy the rest of your DDD event.